This star just exploded and will create a big supernova after years of speculation and anticipation. Betelgeuse, one of the brightest stars in our night sky, is set to explode in 2023. For centuries, Betelgeuse has arguably remained one of the brightest and largest stars in the northern celestial hemisphere, located 642 light-years from Earth. We know that Betelgeuse is nearing the end of its life, and with the star being about 642 light-years away from us, this star is so bright that it is visible to the naked eye. Over the years, this star has stood as the most prominent star in our night sky and is easily recognizable as a reddish dot of light. In 2019, the star was dimming aggressively, and scientists didn't really know what was going on. Many people thought it could be the end of its life. Unfortunately, Betelgeuse dimmed recently, which has rattled astronomers and stargazers. What happened to this bright star, and when will its brightness explode again? Join us as we explain the imminent explosion of this ultra-bright stellar monster. Meet the stellar monster Betelgeuse. Betelgeuse is an interesting celestial object, popularly known for its distinctive red hue and position as a prominent star in the constellation Orion. The centerpiece of the winter sky is undoubtedly the constellation of Orion, the Hunter. At the start of the year, Orion rises in the east as the sky darkens, and it will be up all night. It is easy to recognize and bright enough to be seen even from very light-polluted skies. Its status as a red supergiant and its brightness irregularity make it a subject of constant scientific interest. This has increased fears that it could burst in a wave of supernova explosion, as it is also classified as a red supergiant. Stars like Betelgeuse have masses at least 8 times greater than the Sun and have relatively short and dramatic life cycles. Betelgeuse is estimated to be about 10 million years old, relatively young compared to the Sun, which is about 4.6 billion years old. However, because of its enormous mass, Betelgeuse has burned through its nuclear fuel at an accelerated rate, rapidly fusing hydrogen into helium in its core. Once hydrogen is exhausted, the star begins fusing heavier elements, expanding its outer layers, and transforming into a red supergiant. That's not all. According to astrologers, Betelgeuse was known to be the first star beyond our solar system whose photosphere angular size was measured in 1920. Since then, different studies have reported angular diameters ranging between 0.042 and 0.056 arcseconds. These variations are attributed to factors such as the star's non-spherical shape, limb darkening, where the star appears darker near the edges, pulsations, and how it looks different at various wavelengths of light. Surrounding Betelgeuse is an irregular asymmetric envelope roughly 250 times the star's size, formed by material ejected as the star loses mass. Betelgeuse, one of the brightest stars in the night sky, has been acting strangely. You might remember the dramatic, great dimming of 2019 to 2020, when Betelgeuse's light dropped by nearly 40% when viewed from Earth. Only our Doradus and the Sun have larger apparent sizes than Betelgeuse. Betelgeuse is straightforward to spot because of its brightness. It is often the 10th brightest star in the sky, about 7,500 to 14,000 times brighter than the Sun, and is one of the most prominent stars visible to the naked eye. According to research on the star's size, it was discovered that Betelgeuse is about 700 times bigger than the Sun and around 15 times larger. This star is so gigantic that if we replaced our Sun with Betelgeuse, it would stretch past Jupiter's orbit. Although the size of this star is still uncertain, some scientists have estimated Betelgeuse's mass to be between 10 and 20 times that of the Sun. Also, measuring Betelgeuse's precise distance has been a problem due to various factors, but its current estimate ranges from 400 to 600 light-years. Betelgeuse's total magnitude is approximately -6, indicating its extreme brightness compared to the Sun. Scientists have been unable to determine its actual size because of distance and temperature. According to various NASA scientists, Betelgeuse has already entered a red supergiant phase. During this period, its outer layers have swollen to a size bigger than the star itself. If placed at the center of our solar system, its size would extend out to Jupiter's orbit, further complicating attempts to determine its size. In addition to its incredible size, the star's core is becoming increasingly unstable as heavier elements fuse in its core. According to some sources, the James Webb Space Telescope detected anomalies similar to a supernova event involving Betelgeuse. While that appears to be fake information, it is important to intensify research on the potential impact of such a supernova explosion on Earth. Now we are about to reveal something interesting. After millions of years shining bright, something shocking recently happened to Betelgeuse. It went dim, leaving both ordinary observers and scientific experts in endless debate on the causes of the dimming. Remember when the supergiant star Betelgeuse was dimming in 2019? The star was dimming aggressively, and scientists didn't really know what was going on. Many people thought it could be the end of its life. Some of these contributions can broaden our understanding of why the bright star suddenly went dim and its eventual recovery. In late 2019, Betelgeuse experienced significant dimming, leading to speculation about its impending supernova. While the dimming was unusual, it eventually resolved, and the star returned to its normal brightness. This recent dimming has stirred significant interest and debate among astronomers, the broader scientific community, and some religionists who claim that the sudden dimming is proof that God is the controller of the universe, not the scientists. The fact that Betelgeuse, which was one of the brightest and largest stars visible from Earth, experienced a sudden and dramatic decrease in brightness in late 2019 and early 2020 has stirred a lot of argument and debate about this phenomenon, often referred to as the Great Dimming. The star's brightness dropped by about 50%. This change was both unexpected and unusually rapid. Many also believed it could be a precursor to the star's dramatic explosion or that Betelgeuse played a role in apocalyptic prophecies. However, further observations and studies have revealed that the dimming of Betelgeuse is not a sign of an imminent supernova but rather the result of more complex natural processes occurring within the star itself. This event was so pronounced that it led some to speculate that the star might be on the verge of exploding into a supernova, an outcome that has yet to occur. Betelgeuse typically follows a steady 400-day luminosity cycle where its brightness fluctuates slightly due to natural stellar processes. However, starting in October 2019, its light output began to drop more dramatically than ever observed, raising concerns about when exactly it will explode. If Betelgeuse were to explode, creating a supernova, would it destroy Earth? In February 2020, Betelgeuse's brightness diminished by approximately 35%, making it appear dimmer to Earth observers. This sudden and intense dimming was visually striking and highly unusual for a star like Betelgeuse. Upon further investigation, the dimming appeared to be related to external factors affecting the star's light output rather than an internal collapse. According to an explanation from a scientist, Betelgeuse's recent dimming was analyzed as the formation of a large dust cloud. Partially obscured due to observations using the Hubble Space Telescope, it was revealed that Betelgeuse had experienced a significant gas ejection from its outer layers. This ejected gas eventually cooled and condensed into dust, forming a thick cloud that blocked some of the star's light from reaching Earth. This dust cloud likely formed due to convective processes within the star. Betelgeuse experiences large-scale convection as a red supergiant, where hot gas rises to the surface and cools before sinking back down. In this case, one of these convective cycles appears to have caused an incredibly massive outflow of material, condensing into dust upon reaching the cooler outer regions of space. This dust cloud is believed to be the primary reason for the dramatic drop in Betelgeuse's brightness during the Great Dimming. In addition to the formation of the dust cloud, Betelgeuse's surface temperature also played a role in its dimming. Observations indicate that the star's surface cooled by about 200 degrees Celsius during the Great Dimming. While this temperature change might not seem significant for such a massive star, the cooling was enough to reduce its overall brightness, contributing to the dimming effect observed from Earth. This cooling likely occurred as part of the same convective processes that led to the ejection of material from the star's surface. As the gas rises and cools in these convection cycles, it can temporarily lower the star's temperature and luminosity. In this case, the cooling was enough to exacerbate the effect of the dust cloud, making Betelgeuse appear even dimmer than it otherwise would have. Fortunately, Betelgeuse's dimming did not last forever. Betelgeuse has been acting really weird. Just recently, astronomers saw it dramatically increase in brightness, over 50% brighter than it normally is. The amazing story of its recovery has left more questions than answers. In April 2020, Betelgeuse's brightness began to return to normal levels. As the dust cloud expanded and dispersed, it became less dense, allowing more of the star's light to reach Earth. This gradual brightening indicated that the dimming was a temporary event caused by external factors rather than a sign of any internal changes within the star that might lead to an imminent supernova. Beyond the speculation of stargazers, experts also have their take on the Betelgeuse recovery phenomenon based on observable facts and data. However, different scientific positions on the issue are contradictory. A team of French scientists from Université Côte d'Azur, using the instrument on the European Southern Observatory's Very Large Telescope Interferometer, took high-resolution images of the star from 2018 to 2020. The French team observed that while Betelgeuse appeared dimmer, its photosphere brightened. This suggests that the dimming was likely caused by a burst of silicon monoxide dust ejected from the star, possibly due to a sudden cooling of its surface. The cooling of Betelgeuse's surface might have triggered this dust emission, and when it rescinded, the star brightened up again. According to another study from 2021, Betelgeuse had ejected a gas bubble, which cleared off over time. But things are just getting interesting because scientific explanations of how the dimming phenomenon stopped are contradictory. In 2021, a study published in Nature showed that Betelgeuse's dimming was caused by a cool patch on its surface, leading to a dust cloud that blocked some of its light. Betelgeuse, one of the brightest stars in the night sky, has been acting strangely. Many thought it was due to surface cooling and expelled dust, but now we're learning that Alpha Orionis B's gravitational pull could be stirring up dust clouds that occasionally block Betelgeuse's light. A subsequent study the same year corroborated this finding using detailed spectra obtained from the Weihai Observatory. Their observations, conducted in early 2020, further support the theory of a dust cloud causing the dimming. They noticed that it got bright again after the passing of the dust. Another group of astronomers observing the star during that time concluded that a sudden drop in temperature triggered the gas eruption from its surface. This abrupt cooling would have allowed the escaping gas to condense into solid dust. As a result, this dust would have dispersed, forming a shroud before the star, making it appear dimmer from Earth. As beautiful as Betelgeuse appears from Earth, the looming question remains: when will this red supergiant explode in a spectacular supernova? Such an event would be a once-in-a-lifetime spectacle. According to researchers, a Betelgeuse explosion will be as bright as half of the Moon and visible even during daylight hours for months. Even though we understand it will eventually happen, scientists are still debating the exact timing of this explosion. Let us examine their speculations up close. While astronomers have long predicted that Betelgeuse's supernova would occur within the next 100,000 years, recent research led by Hideyuki Sayo from Tohoku University suggests a much more imminent timeline. Based on the star's current stage of core carbon burning, Sayo and his team estimate that Betelgeuse's core fuel will be depleted within 300 years. Following this, a supernova could occur within a few decades. This groundbreaking study brings the possibility of witnessing this celestial spectacle much closer to reality. Sadly, none of us will be here to witness it. Despite recent advancements in the study of Betelgeuse, scientists acknowledge that it is difficult to precisely determine the star's current stage of life due to the subtle changes in Betelgeuse's surface during the late stages of core carbon burning. Researchers recently suggested that Betelgeuse is in the late stage of core carbon burning, making it a potential candidate for our galaxy's next supernova. Astronomers can only guess the life phase and potential end of the star's life. This uncertainty means that while a supernova could erupt within a few hundred years or even within a few decades, it might extend to any other period within the next 100,000 years. Another interesting question is what a potential explosion of Betelgeuse would feel like from Earth. Massive stars like Betelgeuse explode as Type II supernovae, collapsing rapidly and violently after they use up all their fuel. However, for it to pose a threat to Earth, the supernova would need to occur within 160 light-years of us, and Betelgeuse is about 4 times that distance away. Still, a Betelgeuse supernova could have unexpected effects on Earth. For instance, many animals use the Moon for navigation and may be confused by an unusual light source. Even astronomers would face challenges. Observing the night sky is already difficult when the Moon is bright, and a Betelgeuse supernova would make it even harder. Another notable effect of a Betelgeuse supernova on Earth is its glaring visibility. Despite the long distance between this star and Earth, its explosion could rival the brightness of a full moon for weeks or even months. This supernova would be visible both day and night, casting shadows on Earth during nighttime and altering the appearance of our sky to the point that stargazers are wondering if it will not dominate the night sky. Given its position in the constellation Orion, one of the most recognizable constellations in the night sky, Orion is the most famous constellation there is because it's the most easily identifiable. In fact, when you step out at night and look up at stars, amongst the first ones you look for are the three that make up Orion's belt. The transformation of Betelgeuse from a bright red star to a supernova would be an astronomical event observed by billions of people. It would be a cosmic fireworks display easily visible to the naked eye. There is also concern about the impact of a supernova on our climate. While Betelgeuse's explosion will be incredibly bright, the distance between Earth and Betelgeuse ensures that its energy will not be concentrated enough to cause significant global climate changes. Some scientists claim that a supernova could release enough radiation to slightly deplete the ozone layer, increasing Earth's exposure to ultraviolet light from the sun. However, these effects would be short-term and unlikely to lead to long-term environmental consequences. Earth's biosphere is expected to remain largely unaffected. While Betelgeuse's explosion will not drastically affect Earth's atmosphere or climate, it could offer an opportunity to study how large stellar explosions influence space weather, radiation belts, and atmospheric composition. Data gathered from observing the supernova could enhance our understanding of how past supernovae may have shaped planetary climates or even contributed to mass extinctions. But there is still more to say about its impact on Earth. Studies show that a potential Betelgeuse explosion would significantly help our knowledge from a more astronomical perspective. This giant star has been studied and known to help scientists by providing them with valuable data to examine its composition, the mechanics of its explosion, and the types of heavy elements released into space. These observations have aided our understanding of stellar evolution and supernova mechanisms, offering real-time insights into the life cycle of stars. Also, Betelgeuse's explosion will have significant implications for astrophysics, particularly regarding the formation of neutron stars or black holes. When a big star reaches the end of its life, its center collapses under the pull of gravity. This squeezing together causes the protons and electrons inside the star to merge and form a special kind of star called a neutron star. Betelgeuse might collapse into a neutron star, or if its core is massive enough, form a black hole. Depending on how the supernova unfolds, observing this process would give astronomers an unprecedented opportunity to study the creation of these exotic objects up close. If Betelgeuse eventually explodes, astronomers can study the result to gain more knowledge on the distribution of elements essential for planet formation and life. That is not all. The explosion will eventually become a global event, inspiring art and literature, and bringing a renewed interest in space exploration to our world. It will also reignite public fascination with the universe, similar to how past events like SN 1987A have left us in awe. It will be an agent of civilization on Earth. Although its immediate physical effects on Earth would likely be minimal, the supernova would offer many scientific benefits. In addition to electromagnetic radiation, the explosion will produce gravitational waves, which are ripples that travel outward from a supernova explosion. Gravitational waves were first detected in 2015 and have provided new knowledge about the universe. The collapse of Betelgeuse's core could generate measurable gravitational waves, offering rare data about the internal mechanics of stellar objects. Now, if Betelgeuse eventually explodes, it won't be the first time we have experienced such a spectacle. Let us take a short walk down memory lane and reveal an interesting piece of history: supernova SN 1987A. In February 1987, astronomers witnessed a stellar death process, a supernova that would become one of history's most studied astronomical phenomena. Known as SN 1987A, this supernova was located in the Large Magellanic Cloud, a nearby dwarf galaxy roughly 168,000 light-years from Earth. Its brightness and proximity provided a unique opportunity for researchers to study stellar death processes and the subsequent effects on the surrounding environment. SN 1987A was first observed on February 23, 1987, by Ian Shelton and his colleague, who were using the Las Campanas Observatory in Chile. It was the first naked-eye supernova since Kepler's supernova in 1604. The event, visible to the naked eye in 1987, marked the brightest explosion since Kepler's supernova and quickly became a focal point for astronomers worldwide. Historical records indicate that the 1604 explosion took place at a distance approximately 30 times greater than Betelgeuse, and it was visible during the day for more than 3 weeks. Over the following weeks, the brightness of the 1987 supernova peaked, reaching a magnitude of about 2.9, making it visible to the naked eye. SN 1987A, a Type II supernova in the Large Magellanic Cloud, was the closest observed supernova since 1604. It occurred approximately 168,000 light-years from Earth, providing astronomers an unprecedented opportunity to study stellar collapse in detail. The progenitor star, Sanduleak, was a blue supergiant about 20 times more massive than our Sun. Its collapse and explosion resulted in an enormous shock wave that propelled the star's outer layers into space. One of the critical features of SN 1987A is its light curve, which describes how its brightness changes over time. After its initial peak, the supernova's brightness declined, but this decline was not uniform. Researchers noted several peaks in the light curve, attributed to the interaction of the ejected material with the surrounding interstellar medium. This interaction created shock waves that heated the surrounding gas and dust, causing it to glow brightly. The light from SN 1987A has been observed in various wavelengths, including visible light, ultraviolet, and infrared. This multi-wavelength approach provided a comprehensive view of the physical processes occurring during and after the explosion. By analyzing the spectra of the emitted light, scientists could determine the composition of the ejected material, revealing elements like hydrogen, helium, carbon, and oxygen, which are the building blocks for new stars and planets. The aftermath of supernova 1987A is equally interesting. As the supernova remnant expands, it interacts with the surrounding material, creating a complex structure. Observations have shown that the remnant is rich in significant heavy elements synthesized during the explosion. This is critical for understanding the chemical enrichment of the universe, as supernovae play a key role in distributing elements across space. One notable feature of the SN 1987A remnant is its bipolar structure, which scientists believe results from the asymmetrical explosion. Observations from the Hubble Space Telescope have revealed intricate knots and filaments in the expanding remnant, offering insights into the explosion's dynamics and the remnant's subsequent evolution. SN 1987A has had a lasting impact on the field of astrophysics. It has provided essential data for testing theories of stellar evolution and supernova mechanics. The event has also enhanced our understanding of neutrinos, subatomic particles produced in vast quantities during supernova explosions. SN 1987A was the first supernova observed to emit neutrinos, with detectors worldwide capturing these elusive particles just hours before the optical light reached Earth. A recent study of SN 1987A has influenced how astronomers approach the monitoring of distant supernovae. It has become a benchmark for understanding the life cycle of massive stars and their role in the cosmos. As telescopes continue to improve and more supernovae are discovered, the legacy of SN 1987A will undoubtedly guide future research and deepen our understanding of the universe. Betelgeuse is still the magnificent orange-red star visible to the naked eye at night. As mentioned earlier, the chances are slim that it will go supernova during our lifetime. For now, let's cherish the beauty of Betelgeuse. There is also a need to constantly improve our knowledge of spatial objects. Despite the significant financial and human resources invested in space observation over the past decades, our knowledge of the universe is still relatively pale compared to the daily astronomical anomalies. This is a call for us to support scientific efforts to understand space and the universe. Will Betelgeuse be our next big supernova? Only time will tell. Thank you for staying with us. How soon do you think the Betelgeuse explosion will happen? Share your thoughts with us in the comment section. If you enjoyed the video, like, share, and subscribe to our channel. Also, click the following video on your screen, and you will enjoy it.